Hello, everybody. Welcome back from your spring break. I hope you all had a good time and got a lot of relaxation. Um, Today, what we're going to be doing is going back into chapter 8 and starting section 8.3, which is going to be solving right triangles. Has a little bit of review from the last couple sections we were working on. Let's talk about sine, cosine, and tangent. And sine, cosine, and tangent, we had this acronym, which was SOHCAHTOA. This stood for sine of our angle equals the opposite side, which is what O stands for, over the hypotenuse, which is what the H stands for. Remember, this is all dealing with right triangles. You cannot use this stuff for triangles that are not right. CAH, CA, that's going to be the cosine, equal to the adjacent side over the hypotenuse. Also remember, you pronounce this sine, not sin. Hopefully you guys enjoyed that little joke last time. The last one here, TOA. This is going to be the opposite over the adjacent. So these are the three main trig functions that you guys need to be aware of. If you go on to take trigonometry as its own class, you will get some more functions, but for right now, this is all we're going to be dealing with in this class: the sine, the cosine, the tangent. So just to remind you a little bit as well, I'll go ahead and draw a right triangle so we can get an idea of what this is. And again, this has to be a right triangle. Let's say this is my angle, and I'll call it the Greek letter theta. So I'll put theta up here. It can be x, it can be, whatever you need it to be, but you have to take a trig function of some angle. So if you're looking for theta, this one over here, which is across from it, this is the opposite side. This one here is the adjacent side to this angle. And this one over here is the hypotenuse. Again, the hypotenuse will always be the longest side in the right triangle, and it will always be across from or opposite of the right angle. So what we're going to do today is talk a little bit about not just finding the side lengths of a right triangle, but also how to find the angles of a right triangle. So that's going to be pretty exciting. So the first thing we're going to do is example 1, which we'll talk about specifically how to determine just which angle we're talking about in a triangle given one of the trig functions. So let's say I've got a triangle here. Here's the right angle. Here's angle 1. Here's angle 2. And let's say that over here the hypotenuse is 30.6. Let's say this side here is 27. And let's say this side over here is 14.4. Now, what we're concerned with is, let's say, which angle is angle A. Again, typically, if you're using the one-letter notation, capital letters are going to represent angles, and lowercase letters will represent sides. Here we've also got numbers for the angles. These are not the number of degrees they are. This is just a labeling, angle 1 and angle 2. So what we're going to do is figure out here what angle is angle A if, let's say, the sine of the angle A is equal to 27 over 30.6. So at this point in the lesson, we're not actually trying to figure out specifically what the measure of the angle is, depending on which angle we're talking about here, 1 or 2. We're just trying to figure out which angle is A referencing. Is it referencing angle 1 or is it referencing angle 2? So let's remind ourselves again, the sine of an angle up here is going to be representing the opposite side over the hypotenuse. So that means that the 27 is going to be representing the opposite side, and the 30.6 is going to be representing the hypotenuse. So if we match this up here, the 27 is here, and we know that has to be the opposite side. Well, it's opposite of what angle? Is it opposite of angle 1 or is it opposite of angle 2? Well, it is opposite of angle 1, and we could draw an arrow across there to show that it's across from that angle 1. So that means that angle A is represented by angle 1. So that's the first thing. We're just going to be identifying an angle. We're not going to be solving for it for those types of examples. But we will have some coming up now where we do actually have to solve for the angle and figure out how many degrees it is, which at this point is going to be a good idea for you guys. If you have not gotten your calculators out yet, go ahead and grab a calculator, and I will be back in just a second after you grab your calculator. All right, so here's my calculator. Hopefully you guys have had time to grab yours at this point. For this class, I believe we talked in the last video about the DRG button on your calculators. That's going to be switching between degrees, radians, and gradians. You want to be in degrees or the D mode on your calculator. So make sure if it switches at any point, you locate the DRG button and get it back to the D or the DEG. You do not want rad or grad, or your calculator might say R or it might say G. You do not want those two. You want the degrees. Okay, so now what we're going to be doing is figuring out the inverse function. So let's talk about what an inverse function is. If you've had Algebra 2, this should be a nice review for you. If you haven't had Algebra 2 yet, then this might be a little bit new. So basically what an inverse function does is it's basically an undo button to your original function. So whatever your original function does, this kind of goes backwards and would solve it in the opposite way. That's kind of a really basic level to explain it to you. And specifically with the inverse functions we'll be dealing with here, they're going to be the trig ones. So the trig functions we're going to be dealing with, again, are sine, cosine, and tangent. So the inverse functions are going to be the inverse sine, the inverse cosine, and the inverse tangent. Now, on your calculators, to actually find these buttons, typically they're going to be on the same button as your sine, cosine, and tangent button, but they will probably be above them in those different highlighted colors. And to access them, usually you'll have to hit the second key and then the sine, cosine, or tangent to get the inverse function. And we'll go through some examples here just to make sure your calculators are working out correctly. So, first thing, so let's just do a couple examples here. Example 2, let's find the inverse, well, let me just write it like this here. Find the cosine And here's the way we're going to represent inverse with a -1 power. It is not actually an exponent here. This notation can get kind of tricky, but in this case, it's going to represent inverse. So keep that in mind. This is not a -1 exponent. All right. So the inverse cosine of 0.5. So what you'll do, depending on the calculator you have, you will either type the 0.5 first, and then the second button, and then your cosine. Or if you have the other calculator and just mess around with it a little bit to see which one works, you'll type the second button, then the cosine, and then 0.5, and then equals. So depending on the calculator, just figure out right now which one you have and which way is going to work. And I will tell you the answer should come out to 60. And this is going to be represented degrees. So we'll put our little degree symbol there. So again, mess around with your calculator. Try to get 60 degrees to come out. If you're having calculator issues, please let me know so we can try to solve them and figure out what's going on with your calculator. All right. So let's try another example here. The inverse sine of 0.45. So again, depending on the calculator, you'll either type 0.45 first, and then the second button, and then your sign, or you'll type second button, then the sign, and then 0.45. And once you do that, you should get a value of about 27, and I'll put approximately equals here, to 27 degrees. And just to make sure everything's working properly, let's try an example with the inverse tangent. The inverse tangent of the value 3.2. You'll do the same thing, but instead here you use the tangent. And then once you do that, you should get approximately 73 degrees. So again, make sure your calculator will give you these values. If you're trying a bunch of things, make sure you're in the degrees mode again. Make sure you're typing it in the correct order. And if you're still having issues, let me know, and I'll try to figure it out. Okay. So the next thing we're going to do is actually solve a right triangle. So this is going to be pretty involved. We're going to have a pretty decent amount of work to do, but hopefully a lot of this should be a review. So example 3, solve the right triangle. And I will probably need to go onto another page just as a heads up. So I will try to fit as much as I can down here, and then I'll have to switch. So let's say here we've got a right triangle. Okay. And let's say this side over here is 5. And I will label the different vertices. Angle B here will be our right angle. So over here is 5. This one's going to be 3. And then we do not know what this is. Also, at this point, we don't know what angle A, or what the measure of angle A is. We also do not know what the measure of angle C is. So when we solve a right triangle, what this means, in other words, we need to find the missing side and the missing angles. So we need to get everything. what I'll do is I'll try to keep that in the frame as much as possible while I'm working down here. All right. So the first thing we're gonna do, let's do the easy thing. And that's gonna be to solve for this other side, BC. So BC, this is a right triangle. We know 2 of the side lengths. So we know what to do at this point, which is just Pythagorean theorem. So Pythagorean theorem says that so use Pythagorean theorem. Which is going to be 3 squared, which is the one leg here, AB, plus the missing side squared. The missing side is side BC. And that's going to be equal to our hypotenuse, which is going to be squared, which is 5 squared. Then a little bit of simplification, we can get 9 plus, again, we don't know what this is, so we're just going to leave it as a variable, squared. 5 squared is 25. And then as we do a little more work here, we can subtract 9 from both sides. That's going to give us BC squared equals 16. The way to get rid of a square is to square root it. And that means that BC is going to be the square root of 16, which is 4. Now, typically when you're square rooting, you need to do the plus or minus. However, we're dealing with a shape here, which the length of a side can't be negative. So we're going to assume we're only taking the positive part of that value there. But if you were in a typical algebra class or just solving an algebraic equation, keep in mind we do need to take the plus or minus part of this. All right, so that is 1 out of the 3 parts. Now what we need to do is solve for the angles. So I'll just kind of put that there and show you guys again. Angle A and angle C. We already know angle B is the 90-degree angle or the right angle. So what we're going to need to do is find the angles. Now, let's try to find, so now we're going to find, let's just go in alphabetical order, the measure of angle A. Now what I'm going to do here is only use these 2 numbers that I was given. And the reason for that is in a lot of problems, the numbers will not come out nicely. Like here we got a really, really nice number. This was 4. We didn't have to round that. But a lot of times the numbers might come out as decimals, and we don't want to use those rounded decimals in our calculations further on in the problem. So I'm only going to use these 2 numbers. So if I'm considering angle A, we're dealing with the 3 here, and we're dealing with the 5. Well, the 5 is the hypotenuse, and this side, AB, in relation to angle A, is going to be the adjacent side. So if we looked back at our little SOHCAHTOA thing here, we have the adjacent side and the hypotenuse. And if we look throughout here, that's going to be the cosine. So we want to use the cosine. So we will have cosine of angle A is equal to the adjacent, which is 3, over the hypotenuse, which is 5. Now here's the difference. We're looking for A. So this is where that inverse stuff comes in, which is what we used in the last example when we were typing those inverses into our calculator. So the way to solve this is you're going to take the inverse cosine, and I'll just show you algebraically how it's going to work. Remember in algebra, whatever you do to one side, you have to do the same thing to the other side. So here's what happens. The inverse cosine and the regular cosine, when you compose them, they cancel out with each other. And all that's left is this A, which is exactly what we're looking for. So the measure of angle A is going to be equal to the inverse cosine of 3/5. Now, you can type this into your calculator, again, depending on how your calculator works. But after you do this, you should get that angle A is approximately 53.13 degrees. So now we've found that part of the problem. The last part we have to find is the measure of angle C. So what I'll do now is I'll put this to the side, and I'll try to leave this up here as much as I can for you guys as I'm solving this. So the last part we're gonna have is find the measure of angle C. Now angle C here, again, we're typically not going to use, again, this. You see, this is typically the type of value we're going to get a really disgusting decimal that doesn't round off nicely. So we just have to round it off at a certain number of decimal places. I just did 2 here, but this decimal does continue going. So we don't want to use our values that we've rounded off. So what we'll do is use the values that were given to us, which are this 3 and this 5. So if we're finding the measure of angle C, the 3 is the opposite from that angle. The 5 is going to be, again, the hypotenuse. So if we go back to our original acronym here. So COTOA, S, our sign here, is going to be the opposite and the hypotenuse. So that's the one we're going to want to use. So here, the measure of angle C is going to be, we're going to have the sine of our angle C equals the opposite, which in this case is 3, and the hypotenuse, which is 5. Now, some of you might be thinking, wait a minute, Mr. Hamilton, we had 3/5 in the last problem. How is this any different? Well, what you'll notice is that in the previous problem we used cosine, in this one we're using sine. That's where this is going to be different. Sine and cosine will give different values of the same thing, unless you're dealing with 45, 45, 90 triangles, which this is not one of them. So what we'll do here is the inverse sine of the sine of our angle C, and then we're going to have the inverse sine of our 3/5. Just like before, when you have the inverse and the regular function, and they're the same composed with each other, they cross out. So here, all we're left with is the measure of our angle C, which is what we wanted, is equal to the inverse sine of 3/5, which was the opposite over the hypotenuse again. And when you do this on your calculator, you should get a value of approximately and I'll use the approximate equal signs here. This is approximately 36.87 degrees. And if you add this to your 53.13 that we got in the last one, you will get 90 degrees. Added to your other 90, which we already had, that'll give you the whole 180. But this could be off a little bit. It could be off a couple decimal places, depending on how nasty the decimals get. So just keep that in mind. All right, guys. So hopefully this is making sense. I am still working out how we're going to do like exams and quizzes and all of that stuff. So just stay tuned. I'll be letting you guys know what we decide on that whenever I figure it out. For my joke of the day, While you're social distancing, as a reminder, the word adjacent means next to, so make sure you're not adjacent to anybody. All right, guys, have a good one. I will see you next time.